some weather issues yesterday, and he got stuck in Atlanta. So we had to basically move it for today. So thank you, Joe, for still making it. I know it was hard. I've been working with Joe for a while now. We were part of a startup called Caspita in Silicon Valley. And Caspita was it's been one of the most successful startups on machine learning. Back then, a year or two, where machine learning was something kind of strange, and it was not the buzzword that is nowadays. And then we were acquired by Splunk, and our product, which was Caspita UBA, is now Splunk UBA, right? So Joe still with Splunk. I move on to I'm in a company called Jask.ai. And basically we use not only machine learning, but we're trying to use neural networks. We use a lot of TensorFlow from Google in order to do more detection or enhance detection. Caspita is basically a UBA product. I don't know if you guys are familiar with UBA, user behavior analytics. Jask is what is called a future SOC. The future SOC is something that is not yet sort of out there, but it's basically something that's trying to replace SOC 1. If you've been in a SOC, you know the SOC 1, which is your guy that basically is running scripts and say, okay, there's something wrong, then you escalate, and so on. SOC 2, SOC 3, then you go to CERT. Basically, what we're trying to do is if we are successful, we'll be replacing that guy. So we will have a way of basically replacing your entry-level SOC 1 analyst. We do believe that in the era of big data, security is not humanly scalable. And because it's not humanly scalable, we had to base a lot of our defenses on big data. And right now, if you do big data, there's no other thing to go than Hadoop, right? So if you're not familiar with Hadoop, you should get familiar with Hadoop, with Spark, Scala, Impala, all those, Cloudera. Try Cloudera. Cloudera actually has a very friendly Hadoop distribution, and you can play with it. So today, basically, what we're going to do is we're going to show you a way we're able to detect web shells in compromised perimeter assets. And we're going to use a machine learning algorithm to be able to tell that an asset has been compromised by a web shell. You already saw this. Obviously, if we're going to talk about web shells, we need to talk a little bit about the perimeter. The network perimeter is a boundary between private and locally managed and owned side of a network and the public and usually a provider managed side of a network. So what happens here is a lot of times companies, they firewall up, they harden up, but they have a lot of stuff still that is exposing them. And some of them, we have stuff such as the routers, the firewalls, web servers, API, the REST, stuff like that they need to connect. They need to expose them to the internet. There's no such thing as a company that has nothing exposed to the internet. That's not going to happen, right? It will be either 80 or 443, but something will be exposed, right? So some of them basically, reduce their attack surface. Some others have IoTs like cameras, radio frequency, load balancers, IDS, and then of course we have the common stuff such as servers that do HTTP, DNS, IMAP, SMTP, SSH, VPN, etc. Cloud access, of course, as you're wondering, are as long as you're connected somehow, right? Things such as Okta. Are you guys familiar with Okta? Okay, Okta is a good example of how the cloud, you have a lot of your local internal credentials, right? Okta is a wonderful idea, by the way. I'm all for it, right? Instead of adding 20 more Microsoft servers. Sorry, not to put down a vendor, but so yes. Cloud assets are part of the perimeter. Of course, the perimeter assets are the first line of defense. They're constantly under attack. They're vulnerable to unknown, 0 days. Here's an example, Hartley, shell shock. When I used to work at the Akamai CERT, and shell shock was discovered within an hour of the publication. We were getting hit. You know, the level of skills of attackers varies. You have your script kiddie that goes to exploitation or lit day or back then Millworm. You guys remember Millworm? No, you don't know what Millworm is. Okay, well you need to read some history of hacking. Millworm, you know, Millworm was before anything. So you would download the exploit and then basically throw it at something and see if it works. But then there are people that will basically reverse engineer patches and then craft an exploit, right? So we actually, when we weren't having cooperation from vendors, we try to do that. Like, okay, you're not giving me the POC, then I'm gonna have to reverse your patch. I'm gonna have to figure out what is it that you're trying to defend against. Right? I don't believe in security by obscurity. I had to know what's going on. So obviously, like I said before, you know, an hour later, we were getting hit, right? Now, the thing about this is, think about it back then when I wasn't in that company, it has hundreds of thousands. I don't care how fast you can patch, right? Even if you're given 2 or 3 days of advance notice, it's almost impossible to patch it done. So maybe 1, 2, who knows how many will get bumped. And this is part of having stuff in the perimeter. Defenders must constantly monitor, update, and patch. We've obviously seen that how bad it can go when you don't patch, aka NHS. Last week in England, 12 to 16 hospitals shut down because of WannaCry, for example. Even though it was not a perimeter, they were not patching, right? And they got affected. And I say we because we still do, we rely heavily on static signature technology. And this technology is reactive, right? How many of you were waiting for carbon black signature? How many of you? Last week? No? I don't hear anybody. No. So you already figured it out? You were just reading the news and that was it? I mean, come on. You depend on a signature that will be given to you by your vendor. Either Snort signature, either a McAfee signature, either semantic signature, pen, you name it. Right?
The registry to disable SMBV1.
Okay, that's a good way to prevent it. However, you had to write a GPO and make sure, even forcing reboot, if you had thousands on Windows machines. So that presents a challenge on itself, right? So basically, we still rely heavily on static signature base. And the signature base, unless you see the attack, you cannot come up with a signature, right? And of course, we have the third-party risk. You know, forgotten, shared, co-located, unpatched, unsecure APIs, or absence. We had a case of a pen test we did where we were able to compromise or get into the organization by a third-party server that was forgotten, that was basically had an old version of a mail type of application. That's an example. So this obviously can become unexpected backdoors, or more like front doors, right? That are exposed to the entire world. Is very possible. If anybody was here, took my class or played my CTF, you can actually pre-own an enterprise starting with a web shell, right? And you think, oh, I just have 8443. What can possibly happen? A lot. So most organizations, like I'm trying to tell you, they're only exposed to 8443, so it's logical that web servers are prime targets. Of course, as well as other internet delivered services such as mail, CMS, CRM, development, storage, etc. So here's an example of a person who's going to be our former cyber czar. That's GiulianiSecurity.com. Now take a look at it. This is a picture of the map with GiulianiSecurity.com. Right? Look at all the stuff they have open.
Mine's basic.
use the same credentials. If I'm able to compromise this web server, this mail server, maybe they will use the same credentials for VPN, right? So that is a problem. That is a problem. But we're not trying to put them down, nothing political, but I know, this will bring your attention, right? So this circulated.
Even MySQL, I'm not.
Oh, or Pro FTP. Pro FTP, I mean, come on, man. I used to do Pro FTP on my first CPF. It was like 100 point. Yeah, you can easily compromise that type of software. So that right there, that's an expose right there, an asset that can become the front door for malicious people, even if it's not connected. If it still they're sharing the same credentials, so what I need to find out is maybe what type of VPN software they're using. Are they using other type of remote access that I can reuse the credentials, and so on, right? I wouldn't be surprised if some of the employees actually use the same password for Facebook, the same password for LinkedIn, the same password for their banks, the same password for their health insurance, and that's it, go at it, right? So why use a web shell? Well, first of all, we already said that most of the stuff that is exposed is 80443, so you had to deal with some sort of a web service or a web framework or application. Web shells are usually still, they are compact and multifunctional. They also leverage the programming language used in the web application, so we have PHP, Java, ASP. You can obfuscate commands, and it looks like web traffic. Literally, if you look at a beacon or a web shell traffic, it will be very hard for you, unless you really have a critical eye, it will be very hard for you to detect it. And if you add to that tons and tons of traffic, very, very hard to detect it. Obviously, if you compromise a web server and you just grab that traffic, it's very clear, what you're trying to do. But if you mix that with all kinds of normal traffic, all kinds of other type of traffic, and you have a server that you use for multiple purposes, good luck with that. You're not going to be able to find that. It also gets even better when you use covered channels, right? You can use SSL, DLS. So here's the classic. I love this thing, dude. I love it. It's better than Log Me In. Like, seriously. I remember back then that Student was better than actually RDP. I mean, we're talking, these guys are awesome. This was quoted by a group of Russian hackers. I love this C99. C99 is freaking awesome. And you can do multiple things. You can run commands, you can do directory, you can send yourself shell, you can actually access the database if you need to, fix some records in there, download the database if you need to make a backup, right? So maybe update and patch the server so you can push like a local root exploit. I mean, this is wonderful, wonderful. It's very compact, stealth, and it's, I would say, deadly. From here, you can do many, 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 many other things. So again, I already sort of defined what a web shell is. Here's a definition from the US CERT. It's basically a remote administration tool that is maliciously used against a server that obviously is not yours, and provides you multi functions to update, download data, extract data, and then pivot, possibly internally. So here are another examples of web shells, and the Weebly. The Weebly is actually pretty cool because it's very small and it's small and compact. So if you have like a server that probably doesn't have much memory, it's pretty cool to use. Then you have the VTAG. The VTAG is very popular. It's a Google project. It's almost like a benign web shell. So like if you want to use a web shell and you just want to learn how things work out, probably use that. And then of course the bad guys know about it. So they have their own tool. This is Al-Qaeda web shell. It's called Saudi Arabia. Right? And it's good and backdoor, by the way. If you look at the code, it's going somewhere. So these guys, who have a lot of very competent and technical people as well, have figured out that these things are pretty useful, and they have their own. There are actually certain malicious groups whose expertise is basically targeting things like LAMP, for example, and they already have their tools ready to go. So here's another list of famous or popular web shells. I personally like the PHP Jackal. The PHP Jackal is usually pretty good. It won't be detected, at least with Clamp AV, which is usually what they have on it.
I don't know WSO.
You like it?
I haven't seen WSO get caught on plan.
So these are definitely good tools, and they are effective. If you find stuff like this in one of your servers, you're in serious trouble. Serious trouble. And nowadays, a lot of campaigns what are doing is that they're adding to this picture their ransomware, which we will see in a minute. So just to recap before we move on, this is a number of functions that you can do with web shells. These things are serious. They just don't look cool. You can do all these functions. This also enable all the type of actors that maybe do not have either the level of skill or the knowledge of the operating system of the target to leverage functions in the operating system. So many times the attacker will place a web shell, then will proceed to further access, stealing credentials, capturing traffic, stats, behavior protocols, PCAPs, footprint in the internal network, local root system exploits to escalate privileges. How are they delivered? Here's some examples of how you deliver a web shell. You can do it by cross-site scripting, SQL injection, obviously vulnerabilities in application and services, WordPress or other CMS applications, file processing vulnerabilities like an RFI. Many applications do not sanitize what you are uploading, and then you get code execution by a web shell. Remote file inclusion, local file inclusion. There was, for example, there's another way that's very interesting. I actually developed a challenge in one of my capture the flags where you actually get into the database, you insert the PHP code into a table, you out the table into a file, into a readable, writable directory, and then you browse to it. And bam, there is your web shell. So you go from a SQLite to a web shell. So that can happen. So here's a recent exploit campaign out of 2016 where the vulnerability was kind of all, again, unpatched servers, right? There's the JPOS CVE 2010-0738, CVE 2013-4810, exposed web servers, unloaded web shell, JPOS invoker, CMD, etc. And then from there, if JPOS was running on high privileges, no problem, you already own it. If you don't, then you can upload a local root, depending obviously on the operating system. If applicable, you might be able to basically get a root by a local root exploit, and you can upload the code via the web shell. If it's a Windows box, then they were seen using PSXTech to pivot around. This just a little note. There's some PowerShell now works with Linux as well, so you can execute commands. I was recently playing with PowerShell, and actually you can do pwd, you can do cat in PowerShell Windows. That's pretty cool. That's pretty cool, right? Not that you should be using Windows, but just in case, it's pretty nice that I can use my Linux commands in Windows as well. So after they were able to compromise the actual server, then they proceeded to distribute the ransomware. And then in this case was SAM. And then from there, then you can do many other things. You can run Mimikatz, pass the hash. You're in a domain, then you have a golden ticket, silver ticket, etc. So this is an example. You can start at the perimeter, then maybe hit a DMZ or edge, they have a server, and then from there you pivot internally. I'd like to say this before I pass it to Joe. One of the things that we're seeing in the field is that by the time you get the ransomware node, all the data has already been exfiltrated, right? They already got all your information. They already know your network. Found out of a case of people that were attacked by ransomware and they had good backup, and like in 2 hours, the guys will be back again with the ransomware. They already have persistence, so it doesn't matter if you restore the backup; they will come back in, install again. So if you have clients, be advised that the ransomware may not be just one thing. It may be that, okay, we already got whatever we want. Now we're gonna hit you with ransomware, and you're gonna pay us, right? And then we're gonna hit you again with it, right? So, I mean, I used to say don't pay, but you know, due to the current state of affairs, apparently it's easier to pay than actually try to decrypt this thing. I mean, if last week was an example of anything, right? So with that said, I'm gonna pass it to Joe, and Joe's gonna talk to you about machine learning for security. He's gonna give you some of the technologies and frameworks we use, and then we'll come back and put the entire picture together.
Thanks. All right, thanks, Rod. And so, you know, kind of to segue into this part of the talk, where we're going to just be, I don't know, hopefully also just demystifying like some buzzwords that are really common in like security technologies these days that are like, in our experience as security practitioners, oftentimes like really misappropriated, and this word like machine learning or artificial intelligence, which a computer science term oftentimes just means like sort of fancy search algorithms coupled with other, you know, concrete principles. It's kind of being abused a lot in more just marketing. So like I think just one way to kind of like introduce sort of the philosophy we're kind of overlaying on top of just traditional rules and kind of standard defensive technology is sort of like this sort of new age philosophy of artificial intelligence. And there's just like one little quote I wanted to read to kind of give you guys like a sense of like what really happens at like large scale advanced defensive systems that, for instance, we have examples from biology. So there's this paper we've been kind of reading and adapting some ideas from. It's called Immune System, Adaptation, and Machine Learning. And it's sort of about like how looking at like our own body as like a system of like intrusion detection for outside, let me just read this. So the immune system is a highly evolved biological system whose function is to identify and eliminate foreign material. In order to do this, it must be able to distinguish between foreign molecules, antigens, and the molecules that constitute self. A prerequisite for the performance of this task is a powerful capability for learning, memory, and pattern recognition. So those are sort of like the fundamental things we kind of require from like a machine learning system in general: learning, pattern recognition, and the ability to adapt to new patterns. Given the rich chemical environment present in a highly evolved organism, it is inevitable that foreign organisms will attempt to invade in an effort to make use of these resources. To counteract this, in invertebrates, the immune system has evolved to identify and dispose of foreign materials. This is done in part by antibody molecules that tag foreign material. So this is sort of like the analogy we're going to be kind of like applying in this next couple of slides. Is there's like the body introduces these things called antibodies, and it turns out a typical mammal, such as a mouse or a human, is thought to contain on the order of 10 million to 100 million antibodies. So like in these next slides, we're going to be seeing how we attack this problem with what we call models in machine learning, and just kind of like looking at this paper, if we translate like an antibody to a machine learning model, in general, like for a defensive system like the body, you're going to have on the order of 100 million models playing the game of defense for you. So like when we're playing like we usually have these conversations with like building out a bunch of models for like Fortune 10s who are usually willing to kind of spend for like having a bunch of data scientists in the room, having a bunch of people like Rod. It's very cost prohibitive. And so even in this webshell problem, we're talking about maybe applying 10 machine learning models in combination with rules, indicators of compromise, and just the traditional defense. So like the way we apply this pattern is what we call like shades of gray, and this is kind of about like the layered security, like the layered approach to security, where we're now fusing evidence indicators from kind of multiple sources and multiple categories. It's from like a military white paper called "The Resilient Military Systems and the Advanced Cyber Threat," and that's sort of the reference we'll be using for like the actual kind of schema for how we blend all these different indicators of risk. They could be snort rules, they could be the output of a particular model, and what we kind of do with this is it's kind of like called an evidence fusion philosophy. So for like the delivery of an exploit, for instance, we'll kind of run it's kind of like this little box right here. We basically have like a set of columns. Some of them represent like traditional indicators, like yes or no. Have we seen a particular signature fire for the latest kind of like campaign that has the JBoss vulnerability? On top of that, we'll be running another like a model that we've actually kind of exposed. Like last year, we did a couple presentations at Black Hat Arsenal on this, and this is the GitHub link. But we have sort of a machine learning model that's trained on a bunch of exploit chain samples, and what it's learned to do is detect like just sort of like in the delivery of like sort of the way MIME types change, and a couple other things. Like you'll see like in these exploit chain like examples, you'll see like a MP3 file having a MIME type of like binary octet or something. So there's things that aren't quite right there that we can actually train like an algorithm on to sort of learn some of the patterns if we have enough data samples. So we kind of like open sourced that project. We put all the data there. We basically kind of created this standalone model that's sort of got good at like taking think of it either like row logs for proxy or some sort of like layer 7 proxy data, and we can just run this algorithm that detects whenever a sequence of HTTP events looks like there's a payload being delivered. And so that's sort of like step one in one model. Then there's another model that runs that basically detects when asset changes happen in the perimeter graph. And so this is sort of where we're going to zoom in on like the web shell problem today. And basically this model sort of like, it's kind of like the way the brain works. So like we have this, we kind of going down the list, like the brain sort of like, for my eyes, it gets the sort of sensory input from like the optical nerve. And then from my ears, it gets like the sensory input from the audio kind of, or whatever the signal is from your ear. And basically this is all fused together to like give us sort of a real-time anomaly detection engine. Just kind of like gives us survival instincts. And so we're sort of blending all these models together, like all the way down to like, we have models that run, particularly on the platform Rod and me worked on, where we're kind of doing this like at an enterprise scale. We're running all these models on top of Active Directory at the same time. More for looking like if we have the right host data, like is a ticket being stolen? Are there abuse of Kerberos credentials? And we sort of just like combine all this in basically like an evidence fusion stuff. And that's usually sort of like how you hear a lot of the marketing buzzwords taking place. But I think from a practice, like just a solutions are good for like a category of threat, like maybe like the exploit chain campaigns that we see the exploit kits being leveraged in sort of a large scale phishing campaign where there's kind of like a cyber criminal motivation as opposed to more of like a higher level APT type industrial espionage or kind of just nation state level attacker. We'll sort of apply different solutions, and particularly for machine learning, like it's not really good to like track like a really high level adversary who's kind of we're modeling with like infinite resources, or as Mudge would say, like kind of given the number of lines of code for defense versus offense. Like there's a certain class of threat actor that is probably just it's better to have like a trained operator who's gonna like use technology to sort of to as an augmentation to their like defensive tactics. And kind of like just looking at this stuff at really large scales, I think Google is one of the best examples of like seeing some of these experiments take out at the biggest scales we can see in public space is that some of these like things like machine learning they're just too noisy if we don't apply them in the right context. So this is like from a Stanford. These are sort of just notes from a Stanford class on a graduate class on data mining for cybersecurity. That's the link up there. And basically, this one of the Google engineers who's running these like experiments in the SOC just kind of just went to like where they ended up trying to use machine learning and where they kind of failed. And it turns out that they ended up instead of just kind of using some traditional artificial intelligence techniques, they found it was much better to kind of splice their own custom rule-based language to really give like explainability to each sort of event like an operator is doing triage on. And so they kind of like threw machine learning out the window even at Google for the problem of security. So I think it's important to kind of like come at this stuff with like a lot of just sort of like just kind of being dismissive of the marketing. And so one of my favorite like talks, especially to kind of understand why like some of the stuff Rod was saying, where we're seeing like the advanced threat actors leveraging like a web shell to then inject in-memory malware that doesn't even leave like much persistence on the file system after the campaign's done. Like the CrowdStrike guys really go into this in detail, and some of like the indicators we'll use for kind of at a local level, basically rules are motivated from like the first two links here, and then there's a couple other links that are more just sort of references for kind of like if you wanted to see some of the machine learning that's happened on the web shell problem that's pretty traditional like research. And so one thing Rod and me have worked on is this platform that is sort of a generic like Silicon Valley computer science term called a Lambda architecture. And basically what it means is that we're kind of now leveraging the fact that we can distribute a computer problem across like a cluster using Hadoop, or in this case it's Spark plus Storm, basically like a batch plus a real-time layer. And we're able to sort of like, it's kind of like the fact that now we have these really sort of like next generation distributed systems like Hadoop where we can kind of maintain the state of a lot of problems simultaneously. In this case, we're going to maintain the state of all data of all our web servers in our environment in parallel on sort of like a Spark job, and also at real time as well as batch. And so basically what this reduces to is we'll sort of have like, we just have like, it's kind of like this paper that I was talking about. Like we have many models running in parallel, and some of them are just instances of the same algorithm running per web server. And then we have this global model that's kind of like the way PageRank runs in sort of the web graph. So it's looking at the whole graph of our assets. And basically like kind of what this reduces to, and we'll just sort of walk through the picture in a second of the algorithm, is we have sort of a global model that is sort of like a graph-based model, and then per web server environment we kind of run some more code that runs sort of like in a distributed sense. And so what we're kind of trying to capture is just like a change in an asset graph, for instance. So if we actually are able to identify ahead of time what all our perimeter assets are with an algorithm, with an inventory list, then we can go a step farther, like look at all the IOCs that are detected on all sort of these edges of traffic, and then for each kind of like use case, we run some basically machine learning code on top of it. So there's basically two classes of algorithms I'm describing here. The first one is this is kind of like a PageRank algorithm. PageRank is the algorithm Google uses to sort of like give you like your index results whenever you type something in. And basically the way they compute the algorithm is they have to like build a relationship graph between all the like each edge in Google's model is a hyperlink reference. So the more hyperlinks in general, kind of like, I mean, it's not everything to the algorithm, but basically they build a giant graph of the internet every day, and that's kind of what we're doing per enterprise now. And what ends up happening is like, what we're trying to discover is changes in the relationship graph in sort of a very core sense, because we can start seeing data-driven things. Like we started using this in LAN models when we had enough traffic to see like when all of a sudden, if we know like a member server in Active Directory or a domain controller all of a sudden starts talking to an asset it's never talked to before, another server that it never really reaches out to, strange RDP connections, basically new connections in along with kind of encoding the context of, is this a host? Is this a server? What's the nature of the asset? We just sort of get some low-hanging fruit. And kind of what I mean by that is just sort of like, this is kind of like wrapping up our Rod and mine's last year's DEF CON presentation, which is called like dynamic asset discovery for lateral movement detection. This is sort of wrapping like a 50-minute talk in like 3 slides. But basically what we're doing is we're sort of, for the web shell problem, running this algorithm that takes sort of like an enterprise traffic set. It could be firewall data, bro data, netflow data. It could be PAN's a really good data set, Palo Alto logs. And what we first do is run this algorithm that adds context. So this is like, okay, we have like firewall data. Then we run this sort of machine learning step 1. And what it does is it says like, okay, we think all these things are behaving like web servers. So now even if we don't have an asset list, we can start doing change point detection on each of these asset classes. And basically the third step is kind of like, it's sort of like not really clear from these slides, like what's actually happening each step of the algorithm. But the third step is sort of like, now that we know these different classes, like a user or a server, we can sort of alarm on this change point. So that's kind of like the way we detect sort of changes in this web shell graph that happens at the higher layer. And then basically each one of the assets we discover in this graph, we run a local model on. And this local model sort of like is actually just stuff like Rod actually ran some attack scenarios just to generate data we could show you. And this is kind of like now blending a bunch of, we can use rules, we could use IOCs, or we can run like a machine learning kind of augmentation on top of these rules. And that's actually what's happening in this case. I'll let Rod talk through the data here.
Yeah. So basically, what we did is I created a data set, right? And the data set, obviously, you had to label the data. I had to explain to him. This is also goes for you. Eventually, you're going to start dealing with machine learning stuff, where basically we had to identify stuff such as rare time on site usage, rare time stamping on creation of files, rare connection patterns, large number of post get requests to a specific file, connection strings with command arguments, cmd.exe, bin bash, for example, unusual direct connections to files exposed to the internet, unusual user behavior in comparison to normal traffic patterns. So, for example, you can see that some users, for example, had like a pattern of using the site, and then all of a sudden you have this user that's just connecting to a single file, right? And then it can be under a cover channel. It can be under SSL. And then if you have deep backend inspection, then you start seeing things like this. Oh, you got a problem, dude. You got a problem. But it's not easy to do this. I mean, I need you to understand that this is a problem on scale. In order for us to compute all this, like in a real enterprise, you need to have a back end that can do that, right? A train operator can do that. I am the train operator. I am the trainer. But in order for the learner, the algorithm, to understand this, you had to have a back end. You had to have a plausible algorithm. You had to have a guy like Joe, right? And then like a baby, we need to train the algorithm and tell it when you see all these things, something's going on. Something is wrong, right? So here we just apply the label, right, to what we believe is a behavioral, right, pattern of use of a web shell. Are you following me to this point? Okay. So basically, we did a proof of concept, right? And the one that I'm going to show up in here is a classic remote file inclusion with my favorite web shell, C99, right? So we're gonna try to make this easy to understand, right? We're skipping a lot of what's behind the algorithms, and so basically here's an example, right? So here's the pattern of attack. So look how actually I did this, and look how I go from links. These are referrals, right? Referrals about the user is navigating the actual target, right? WP-login, WP-admin, that tells me that he got in. For example, the user got in. I don't know if you're sure, if you're familiar with WordPress, you should be very familiar with what I'm showing right here, right? Oh, plugins, yeah, well, yeah, no, plugins, you're just looking for it, dude. So basically, the following is the that shows the attacker accessing the post feature and uploading the C99 web shell, bypassing the sanitation controls by basically adding a JPG extension, right, to the actual C99. We can try to find it here, right? And then basically, as the attacker uploads the web shell, then you can see how the attacker will go eventually hit it, right? Remember, we're comparing this with other traffic because you had to provide a benchmark, a baseline of what normal traffic is, right? Machines need to be taught. If you don't tell them what is wrong, it won't be able to discern what is it that we're looking for. And that's usually one of the biggest challenges is the quality of the data sets and the process of labeling. And in the process of labeling, in order to do correctly, you need people like us that are good at whatever they do, but they are very specific and they know how to label the data correctly so you don't get a bunch of false positives. So I cut off a little bit of the data so it's more humanly readable. We're going to publish this eventually, and the talk will be online as well. But here's where I actually, after I uploaded the C99, I sent myself shell back. And I did it because I wanted to see if we could capture it via the logs. We use proxy logs on this one, right? That looks like proxy logs, right? So I was also capturing Picas as well. So I was trying to see if we could get info from Bro or from the Pica itself. And basically, as you can see, and actually, let me go back here because this is where the money is. By applying this, right, to the framework we previously explained, then we created a model that will look for all this stuff, compare with the baseline, the benchmark behaviors, and say, there is a web shell here. So I'm not sure if you want to give a little bit more of the back end behind all this obscure technology.
So I think, and there's actually some appendix slides. Like we had to do this talk once before, so there's a couple slides in the appendix I'll jump to. But just to sort of reiterate, and it's kind of like not very clear from what's happening here. But basically, the notation is that there's sort of like a global model that's working in tandem with things that happen per IP address, and per IP address. Like it's like indicators of compromise are great. Like if we have rules, if we have AV, whatever we can use, it's we don't want to throw any of that away. But if we are able to sort of build some state about like just keep track of statistics that let us like for the web shell problem, especially like when you listen to the Mandiant, the CrowdStrike guys talk, like it's just about the ability to say like when there's a new path. Like relative to the old data that like minus dynamic content, maybe like one person is going to that no one else in the entire, and this could be like a shopping cart application. So it's just like, there's like a lot of low hanging fruit if you can just kind of build enough of a statistical profile. So oftentimes that's what we mean from like a low hanging fruit. And that statistical profile is sort of one component in this decomposition that I think, let me just kind of jump to. So let me see if we have this. Oh man, this is kind of ugly. Let me just show you. I want to show kind of one other slide that's like a little bit better written, and it's just I should have copied this sooner, but bear with me here. We have we did 6 presentations last year. So I always I'm always trying to take the coolest part of the slides. I think this is just sort of it's more just to educate and just kind of share some tribal knowledge on what a lot of all these buzzwords mean. And this is sort of one of the favorite things. I kind of left this out of on accident. But basically what I wanted to sort of show you, there's sort of learning means a lot of things. But one of the crazy things, if you start studying computer science and you start seeing even when I'm speaking right now, language is taking something that's in my brain, who knows sort of how high dimensional my thoughts are, and now we're using words as a protocol where there's already compression from what's in my brain to the words you're hearing now. And so there's an analogy there that's really deep in the idea of what does it mean to learn. So it's also for instance survival instincts, certain things you don't want to have to relearn. So that's kind of one of the things we try to engineer on a big data platform that's really complicated actually. And it's if I stuck my when I was little, I stuck a fork in the electrical outlet, and then I learned sort of I'll never do that again, because now each time I look at an electrical outlet in metal, I sort of have a little hash of the memory where I can do a quick lookup as opposed to feel the whole experience again. And so I think it's a kind of a dumb analogy, but if we just look at this little piece of code that's going to happen here, this is sort of and we've probably all done this in one form or another. Maybe you didn't even realize it. When you train a linear regression, it's called, or basically you fit a line to some data. What you're doing is you're creating an algorithm that now you don't need to use the data anymore. You just need to use the coefficients of that line as a lookup for your prediction. So it's a hash of the data. And so here we're just going to run this linear regression on a open source tool called R, and we'll show what the output is. So we're taking basically this open source data set. It's just some benign data set about cars, and we're going to make a sort of a benign prediction that's saying, so we're fitting a linear model that says in this data set there's miles per gallon, and then there's some other variables. There's weight, displacement of a car, the number of cylinders. So we're basically saying there's just sort of a statistical hypothesis here that miles per gallon has a linear relationship between weight, displacement, and the number of cylinders. Just some toy model. And then when we run this code in R, the output of taking all this data is these 4 well, there's more data here, but kind of think of the key thing we really need is these 4 parameters. And then when we run a machine learning model, there's basically now you throw all this data away, and now you do a lookup. And so this is really what's happening in really big enterprises is they're monetizing their data sets. So when we kind of the global model we were talking about, that's sort of what we're doing here for the enterprise. Is if you have a really big customer like the oil and gas companies of the world, or the banks of the world, they take all this data and they monetize it security-wise even, and create a hash of their sort of signal. And that's kind of what's happening here under the hood with machine learning. It's nothing mysterious. It's brittle actually. And so so what ends up happening for us is when we're as a computer science problem we've had to solve in general is now for every model the system Rod and me worked on for 2 years. After 2 years they have about 60 models that all fit into this API that basically has to this is a really kind of dense slide, but basically what it's trying to capture is that for every model, as an author of the model, as a code, because I own the code, I have to satisfy a contract that makes me define how the model learns, how it forgets, and how it processes new data. And this is sort of a super non-trivial learning problem that's sort of we through 3 billion years of evolution kind of get for free. But when you have to engineer this stuff, it's not trivial at all. And I think in this case, it's really so when we hear a new solution that's using machine learning for security, there's a lot of these things that are subtleties that are under the hood that I don't know. I think I just find these examples useful more just from an interesting perspective. So I hope that was helpful.
That's cool. Any questions? Yeah, stand out because we're gonna be bombarded by questions. Go ahead.
Yeah,
Well, yeah. I mean, it depends on the data that you're using and the
And
type
this
of
problem we
indicators.
talked about is actually like we're using it for like many problems so we're using sort of two models. The global model is like a graph of all the assets in the enterprise. So we use it for like basically any anomalies on edges in a network graph. So that there's a lot of use cases there. So part of it was like, have you ever heard of the shadow IT problem? Like when I used to work for healthcare, like part of what was happening with healthcare is like people would plug biomed devices in without even going through a proper asset management process. And then there'd be all these crazy vulnerable like things that had running Windows XP, like they wouldn't be patched and they wouldn't even be on like a spreadsheet. So one of these like part of the low hanging fruit is just running a model that discovers things that you don't know about that are part of the shadow IT profile. And then also it is like, okay, if I have enough data, because it's this value extraction process. Machine learning is good about taking all that network data and then saying like, okay, giving us a statistical probability, like this IP address behaves 90% of the time like a FTP server, or this looks like a AD server. And so we can just use data, especially in a really large enterprise where they already kind of have all the other toys and regular solutions, then they're sort of augmenting the problem. And that's the right thing to do. That's where we see this kind of effective is at the higher, like the Fortune 10s, because a lot of these problems are just really cost prohibitive. Like to extract data just takes a lot of money and like usually not just like, it's just a bunch of engineering work really. Does that help answer your question?
Did that answer your question?
So
yeah.
Okay, that's a good question. I wanted to mention that, right? So like there's two feature vectors. There's the global feature vector, and then per IP address, we run a local feature vector. For different models, so for this webshell model, I'd say, think of those like in that, those examples Rod went through, like was like rare user agent, rare like path. Each one of those is a feature. Maybe I probably should have counted, it's around 45 features just for that model. In our command and control, our covert channel model, 90 features per IP address. This is like this is the fusion of evidence, right? So each one of those, and I think evidence is additive too. So we apply pretty benign. We could run a heuristic. Like, have we seen anything interesting? We could just put like a algorithm that says if we've seen enough like non-zero columns, this is risky enough to investigate. Or we can take an optimization and run like a random forest on that feature vector, which we've done in some cases. But oftentimes like a heuristic to just add enough indicators of risk is good if we have enough columns.
That's like can detect something wrong.
Like the true positive, false positive. Like, you know, it kind of varies. It's nothing crazy because also to measure that, we need data samples of like ground truth. So on ground truth, like we did this one example for a pretty large, like semiconductor manufacturer, I would say. For like this example we had, I'm trying to think of the number of, so they call this a class imbalance problem. So I think we take like lots of users' benign traffic, then infection traffic or like web shell pops in this case. So to have like in our examples, we had like a class imbalance of 200 malicious labels and 60,000 benign. And we get like a true positive ratio around 60 to 70% usually in that case. But it's usually like, this is usually like, at that point, if we're talking about security, like, we talk to like a bank, like one of the top 10 banks, they have 400 labeled instances going from like QRadar to Archer per month. And that's like the highest and most mature, like there's a culture of machine learning that most of these SOCs are just starting to learn. And part of it is like, we'll talk to people who keep their evidence collection processes. Some of the team is keeping it like WordPad, some of it's keeping it like Excel. And there's no way for a system like this to learn from the operator output. So part of the goal is just like start creating labels, like and we really don't know what that looks like globally. So just like doing that true positive thing is an exercise we did on a single enterprise. But that could just be their data has a special property, or so we don't really know these questions at a global level. I mean, military does, like certain high level organizations do, but like kind of mid range bank or whatever doesn't.
Right. I mean, if you worked in this area, you understand that it's very difficult. It's very challenging. There's ETL nightmares. I mean, they were just saying ETL. I'm already, oh my God, there's going to be a problem, right? And even when you get it right, and then you go to a customer, they may still send you bad stuff, and that screws up everything. And actually, sometimes it skews the actual analysis. I'll give you an example. Certain API, like SurfLayer, for example, certain CDMs, they behave in many instances like a botnet. It has a DGA, a bunch of ND5 hash or something is going out, has a beaconing pattern, and sometimes there are command strings right there. That's a botnet. That looks a lot like a botnet, so this presents a problem, right? And the more labels, the more type of feature sets we're able to apply, the better chance we have to teach these things to say, okay, well, that is a CDN. That's not malicious. Right? Absolutely. There is lately, I mean, people's been putting Hadoop down lately. Many people are shifting sort of like to the TensorFlow thing. By the way, we're going to release an updated version of Acteon, which is our open source project. Hopefully, we'll be able to show with a Black Hat Arsenal where it's going to be rewritten in Python. It's going to be using TensorFlow. And also, I'll give you also another tool that we'll be releasing soon is it's a blue team tool that tests actual IDS sensors. It creates traffic. And eventually what we're going to do is we're going to add machine learning to it. So basically the tool is going to send information, see how your sensors respond, and then introduce gradual changes to see if you can bypass it. So basically it's going to be like a sort of like a machine learning tool that tests your IDS, your firewall, your WAF, and then eventually we'll get to some sort of an indicator of how bad your firewall is misconfigured. Any other questions? Yes, sir.
You mentioned how else earlier. Do you use the default API for reports that are built in the data sets there, or do you actually generate custom asynchronous?
Well, Pan, if you're using Pan, you can use syslog, right? Which it skips a lot of the ETL, right? And you send the syslog to a SIM. Oh yeah. And well.
We have to deal with it. We're thinking about it like a platform perspective. So part of it was one of the assumptions is we never would have access to config on. Typically, the enterprises give us the logs and they don't even tell us what they we don't even know if they've turned on what is that the web the web filter. Some of them won't actually be logging kind of toxic layer data with some of the additional modules. But it's kind of variable, and our ETL 90% of the platform code we worked on in our original when we were at a startup was ETL code because we sort of had to handle so many variables and that's the it's just and that's the inevitable problem with security is the schemas just are constantly it's not like pharmaceuticals where in pharmaceuticals the schemas are so rich and you can trace back drug interactions, but in security we just constantly engineering new products, and I think that's where all these products are ending up. Kind of part of the big problem is just giving a normalized data set.
Correct. That's actually one of the biggest challenges. Sometimes I say machine learning is like printers, grab in, grab out, right? So I can give you an instance of a customer that all their VPN concentrators were completely screwed up. And of course, the model says, hey, there's people connecting from all these weird places. It's what the machine is looking at, but then when you check their configuration, it's completely screwed up. So you were feeding me crap, comes back at it. So yes, there's a lot of buzz and there's a lot of snake oil, but it's also sometimes you need to consider there are many factors of this technology to make it work, and we're actually addressing it right now. I mean, sometimes some enterprises they don't have their stuff together, right? Their firewalls are not configured right. The data that they're sending you is incorrect. Then all what you're gonna come back with is crap, and the analysis will be shifted or will be slanted, or it would be wrong because it's not truly what we're trying to measure. Any other question? Well, thank you very much for coming to our talk.